So I just got off my soapbox with you. Get your Learn Smarts done. Get your homework started. If you need help, come in and get help. But do 9 right now. Okay, even if you don't have the rest of them done, do 9. So when you hit the 9 test, you'll be good. Today, this is what we're doing. We're going to learn a little bit about titrations, and we're going to go back in lab and we're going to do the titration. Okay? Don't forget about your Part A, your home lab. Before you go back in lab, you need to have Part C done. I will not let you back in lab until that part is done. Okay? Now, titration, what is it? Basically, this is a technique that we use to figure out the concentration of some unknown. We know it's an acid, we know it's a base, we can get a specific volume of it, but we don't know the concentration, and that's very important. So it's a technique we use. We're going to learn it today in lab. I'm going to go through it here before we go back in lab. Our first titration, I'm going to have you all do with me. Every single person is going to have hands-on doing a titration. Okay? The equivalence point, you need to know the difference between these. An equivalence point is where my hydrogens and my hydroxides are equal. This is where my pH is 7. That's equivalence. My end point is when I'm using an indicator and it changed colors. And it shows me, oh, that's where I should stop. But depending on where the indicator changed colors, depends on what pH it is. So it's not necessarily 7. It could be 8 or 9. It could be 2 or 3, depending on when my indicator changed colors. And you sort of learned that a little bit last time when we were doing Part B, right? It took more acid or less acid to change the color when you were trying to change your indicator, what that was acid or base. So basic thing, titration, we can figure out an unknown concentration. Equivalence point, that's when hydrogens and hydroxides are equal, where I have a pH of 7. End point is just when my color has changed on my indicator. Okay?
Wait.
Yes.
So the equivalence point is when the hydrogens and what
Hydroxides
hydroxides
are equal and you get a pH of 7. Okay, any questions with these? Because you need to know these terms and need to be able to go back and forth because she will test you on equivalence versus endpoint.
So equivalence always equals 7.
Equivalence is 7. That's when I'm equal acid and base. Okay, endpoint is just when my color changed. So if I chose the wrong indicator in my titration, then it might change when I'm going between 2 and 3, and I haven't got that equivalence point yet. Okay, so endpoint is just when my indicators changed. You okay to go forward? Got main ideas? Okay, this is what we're going to do to set up for a titration with a pH meter. We're going to do 2 titrations first without a pH meter, the old-fashioned way, just to get the feel of the titration, because they're fast. You always want to do a quick, fast, dirty titration is what I call it, right up front, because that tells you on the pH one where you have to set up and do all these fancy things, where I'm looking for the change. Where about do I need to slow down so I don't miss it and have to do the whole thing over again? So you always want to do a quick titration first. That's what everybody, when we go back, is going to get a chance to do a titration. Okay, you're actually going to get to do 2. We're going to be working with molarity. Remember, molarity is moles over liters. We're also going to be working with our favorite equation, C1V1 equals C2V2, our dilution equation. Okay, it works here too. This is a titration curve where I have a base in the bottom and I'm titrating with acid. That means I'm dropping acid into the base. We get to a point where all of a sudden, boom, it goes. The equivalence point is 7. Okay, that's the point that I'm looking for. If I haven't chosen a indicator that changes right here, maybe it changes between 8 and 9. I might not be right at my equivalence point. I might not be able to tell exactly the volume of acid, okay, or exactly the pH, but I'll know it's changed. So we're looking for this. This is the kind of curve. Now, if we started with an acid, it would go backwards. We'd start low and we'd go up high, okay, and that's what we're going to be doing. We're going to be having our unknown acid in the bottom. We're going to be titrating with known hydroxide. This is an acid that has 2 hydrogens that it can't give off. Remember I told you only one can go off at a time? So we get a curve that has 2 places where those hydrogens come off. If I had 3, it would have 3 bumps. The ones past the first one are usually much smaller and get even smaller. okay, as you go on. Acid-base indicators are what we were using last time in lab. What basically is, it has one color when the hydrogen's on, it has a different color when the hydrogen's off. And because of that, and they're usually weak acids or weak bases, so that's why we only want to put 1 or 2 drops in, because if you put too much in, then it acts as a buffer, and it doesn't let your reaction work. Okay, but these are sensitive to colors. That's a big thing with this. Indicators are sensitive to colors. Okay. Again, I will post this up online, so if you want to go back over it, if I go too fast, because I'm trying to get us in lab, it'll be there. Okay? This is the indicator, universal indicator. This was what was on your pH paper. It's actually a combination of like 3 different chemicals. And it gives us a wide range of colors so we can quickly tell what's going on. You used a universal indicator last time in part B. And if you notice, as you went on that universal indicator, it changed several different colors. You might have stopped when it changed the first color, but if you kept going, it would have gone through all the colors of the rainbow, which is sort of cool. Okay, pH.
How does it do that if you're just bringing?
Because we've got 3 different chemicals, and each of those 3 different chemicals changes to a different color each time, and it's sort of like the color wheel. So if I have a blue and a green, or a blue and a yellow, it makes green. So that's how we get the colors in between. Okay, you are working with pH paper at home. You should be seeing that it works like the universal indicator, because that basically is what it has. Today we're going to be working with a pH meter. It's going to be hooked up to your calculator, so as you go back into lab, make sure you grab a calculator. Okay, we'll be doing those. Now, determine the number of moles of KOH that can be neutralized by that much NaCl. All you're doing is solving for moles. So it's just the molarity equation, which is molarity is equal to moles divided by liters. You're solving for moles. So moles are equal to molarity times liters. So plugging in to get this into liters, divide it by 1,000, right? So it's 0.45 liters times 1.4 moles, or molarity, and that would give me how many moles of HCl would need to be neutralized. Since KOH has 1 and H has 1, it's a 1-to-1 ratio. So whatever moles of HCl, I'd need that many moles of NaOH. Somebody got a calculator, throw that through for me.
0.63.
163?
0.63.
0.63, thank you. Okay, so then I would need 0.63 moles of NaOH, is what they were asking. How much would I need? Okay?
Wait, how do we know? I thought we found HCl.
We did, but since it has 1 H and 1 OH, I'd need the same amount of each.
So we do that whenever it says that it needs to be neutralized.
Right. Okay, so let's do this. And they haven't given me a volume, okay, for the KOH. So on this one right here, we're going to do the same thing. We're going to divide this by 1,000 to get it into liters. We're going to take moles are equal to molarity times liters. Plugging in, molarity is 6.5 molar times, when I put that into 0.03, right? Liters. I put it into liters. Times those two together, what do I get? 195. Okay, and that is moles of HNO3. Again, HNO3 only has 1 H, right? And OH only has 1 OH. So whatever I need of however many moles of nitric acid I have, I need that many moles of potassium hydroxide. That should have been potassium too, sorry.
What would be the situation where it's different?
Okay, we'll get there. All right, there are tons and tons of different kinds of indicators that we can use. I gave you this chart on yours. It's not colored, but it gives you sort of the idea of where it changes. We had a few that we played with in lab, And you probably noticed that some changed really fast when we were adding acid or base to it, others didn't. That's because when we do different titrations, if we're working with different pHs, we don't want to miss that curve. It might not curve up as much as the strong acid, strong base. We might just have a little teeny curve, and we've got to catch it within that little amount of area. Yes?
So is a titration like another way to measure the pH level?
We're not really measuring the pH. We're using the pH to tell us when things are equal.
Oh, it's like an equilibrium.
Right, sort of. So to give you an idea, in order to choose an indicator, I want the indicator to change colors in this area right here. So if I start right here with my base and it's already in this area that's going to change, the phenolphthalein goes from pink to clear before I've even started my steep part of my curve. So it's going to tell me the end point is before the equivalence. Okay? So I want to choose something that will change colors in this steep area. So that's how I choose my indicator. Here we've got methyl orange that we're using. Here we've got methyl red. We could also use thymol blue. Notice it's still changing in that steep area, and it's between the equivalence points. So it would still give me close to what I need for calculations. Okay. Mostly they're weak acid, weak base that we're working with in order to get it. If I've got two hydrogens coming off, I want to take and use an indicator that will change when the first one comes off and one that will change again when the second one comes off. So I can do the titration all in one. Okay? We want the change in the indicator again to be close to the equivalence point at each point. So the equivalence point here would be about right there, and here would be about right there. Okay, and that they're not necessarily, when I'm talking equivalence point to take those off, here it's not necessarily 7, because when you have more than one hydrogen coming off, you're not going to hit 7. Okay? So it's where you're in the curve, it's the point at which help me mathematicians, when the curve goes from this way to going this way. What's that called? Math. No, you're going this way and then it switches and goes this way on the curve. No, there's a name for it. It's slipping my brain right now. So you have a curve and it has this kind of slope, and then all of a sudden it changes and comes this way. And it's this point where it changes that we're looking for.
So we're just looking at the changing point. So where it's instead of just going.
I can't remember what it's called. I will find it and get back with you. Okay. So this is what we're going to do. This is a quick titration when we get back there. Okay, we're going to set up the burettes. We've got brand new burettes, so they should be beautiful. I'm making all of you open them up because I didn't want to open all those boxes by myself, so you guys get to. Throw the boxes away. Okay, you're going to set it up in here like this. You're going to prime it. What does prime mean? You're going to wash a little bit of the solid or the solution through. We're going to put NaOH in this burette. So we're going to wash just a little bit through, 2 to 3 milliliters. We do that so that we can test and see that this part right here, it's called a stopcock, will actually turn and allow things to drop. Okay? And we want to make sure it drops nice. Down here, we don't want to put our flask in until we've used, I call it a garbage beaker, to test that, to make sure it's dripping. Okay? Then we're going to close it off. This, when you're looking at a stopcock, is open. This is closed.
So
Okay?
we're doing a garbage experiment before a garbage experiment?
So it's just to rinse. It's really to rinse the burette. So we're rinsing the burette. Once you find out this is dropping, you're going to fill it up to the top. So your top mark is 0. You want to fill it up above and then carefully bring it down so the meniscus is right at the top of that top line. Okay? Then you're going to set aside your garbage beaker, and in your flask, you're going to put a specific amount of, I forgot to put here, okay, I've got to get these out. We're going to put 10 milliliters of our HCl down here, and we're going to put 1 to 2 drops of phenolphthalein. Okay, down there. Now we're going to put it under, and you're going to sort of swirl the flask as you drop in. As the drops hit the liquid, it will turn pink, but then it'll go clear.
What do we stir it with? The
You're just going to stir it
Oh,
with your hand. Okay, so you're just going to sit there and stir it with your hand as you're dropping it. So you're holding this with one hand, you're stirring this with the other hand. As this turns pink for 30 seconds, it stays there, you stop. Okay, even if it fades after, it's okay. 30 seconds is your key thing. Okay, and you're going to read the the burette down. So you're finding out how much that you used. You're reading it down. Okay, make sure this is open, so make sure you put it closed when you're done. Okay, this really quickly goes over the steps. You add your known molar always goes in the burette. So if I know the concentration, it goes in the burette. What I don't know goes into the flask, but I know the amount I put in there. Okay, you add an indicator. You add drop by drop. So the color changes. This is called neutralization, and it is a titration. Okay, and we stop. The difference between this one and the pH one, this one you use a flask. A pH one you use a beaker, and you put the pH probe in. So you're going to put the pH probe in, and you're going to use a stirring rod, and you got to be really careful that the stirring rod does not hit the pH probe, because the pH probe has a very thin layer of glass. And if that stirring rod hits that thin layer of glass, what do you think is going to happen? It's going to shatter, and they're about $105 each. So you need to be really careful with this. You don't want it stirring really fast, you just want it to stir. Okay? Now, you're going to set it up the same way. They show up, I always like to zero mine out after I do titration, because I hate starting at partway through like 10.6 and then ending at 24.3 and then have to take 24.3 minus 10.6. You can do it, no big deal. I just hate doing that, so I re-zero each time. It's up to you how you want to do
can you
that.
just add more water on the top each time?
Not water,
Oh,
sodium hydroxide. Yes. Okay, so when we get back there, when we start doing the one with the pH probe, I am going to walk you step by step through this one too, because the next time you're going to do 2 other titrations with the pH probe, and those 2 are going to be with soda pop and with vinegar. So you're going to titrate both of those by yourself. So we're going to go through it together. Okay, examples of writing all the hydrogens, equation neutralization. This is just rewriting equations. You guys know how to do this, right? Lithium hydroxide plus acetic acid. You got to look up this acetate, but it's acetic acid. When they react, they're going to go OI, outsides and insides go together. You remember how to do this? Coming back to you. Lithium acetate is your salt, and then you have water. Okay, what's sodium hydroxide? NaOH plus phosphoric acid. What's that? Where does it come from? You need to know these. Phosphate is PO4. Do you know the charge on PO4? -3. So how many hydrogens am I going to need? 3. Okay, now this one is going to need to be balanced when we're done, right? But I'm still going to do OI. Outsides are going to go together, insides are going to go together. I know I'm going to make a salt. I'm going to need 3 sodiums to go with the phosphate. Plus I'm going to get water. But it's not balanced. What do I need to do to balance it? This one gets a little tricky. I want to get to you got it?
2 in front of the water.
2 in front of the water is not going to quite cut it, because I got 4 and 2. That would make 4 hydrogens, but I've got 3 sodiums, but they're not balanced.
You added 2 in front of the second. I lost.
So what if we put a 3 here? Let's just work it through. I put a 3 there. 3 sodiums, 3 sodiums. 1 phosphate, 1 phosphate. Then I have 3 hydrogens, 3 hydrogens, and I need 6 hydrogens over here. If I put a 3 here, and then that extra 3 oxygens taken care of. Found it? Okay, barium hydroxide, what is it? OH But what's the charge on BA? 2. So I need 2 hydroxides. Plus, what's hydrochloric acid? HCl. Okay, this is another one we're going to have to balance because there's 2 hydroxides versus 1 hydrogen, right? So coming over here, what we get, we always get water, we know that. And what else? Barium, chloride, barium's plus 2, chlorine's minus 1, so I need 2 of them. Okay, what do I need to do to balance it?
2 bariums. No, bariums are fine.
Bariums are fine, 1 to 1. 2 HCl, okay, and when I do that, what else do I need? 2 waters, good. So look at number 2. I need 3 times as much base to balance out this acid. Look at number 3. I need twice as much acid to balance out that base. So that's going to cause a little bit of problems. Okay, let's look at this really fast. This is one of some of your pre-lab that you should have done. I'm going to show you something really fast. I don't think it, oh it does. Okay, we're not going to do the long version. We're going to go to the short version. Okay. If you want to look at the long version, you can look at it online, but I'm going to do short version. Okay, so for this, hydroxide to hydrogen, 1 to 1, right? 1 to 1. Because it's 1 to 1, I can use C1V1 equals C2V2. I can also rename that concentration of acid times the volume of acid equals concentration of base times the volume of base. Now, if it wasn't 1 to 1, I would put in front of the acid the number of hydrogens. And in front of the base here, I put the number of hydroxides. I'm running out of room to write there. Okay, that's the only difference. So it's still C1V1 equals C2V2. But if it's not 1 to 1, I have to add in how many of each I have. Okay, so going forward here, C1V1, I plug in everything I know. Solve for what I don't know. I don't know C1. So plugging in, I find the concentration of the acid. So here I did not know concentration of the acid. Okay, so if you just remember C1V1 equals C2V2 from our dilution equation, substitute acid on one side, base on the other side, you got it. Makes it very simple. We've already done this. Okay, so really quickly going through this, I have, what is it?
0.5.
Concentration of base, right? OH is a base. Concentration of base, so 0.15 molar. What do I have next? 15 milliliters. What is that of? It's of this acid. So I have volume of an acid is 15 milliliters. I have concentration of an acid, 0.10 molar. Okay? So we're using CaVa equals Cb Vb. This is a 1-to-1 relationship. So I don't even have to worry about anything else. I don't know what the volume of the base is. So I'm solving for volume of the base. Volume of the base is equal to concentration of the acid, volume of the acid divided by concentration of the base. Throw it in. Throw the numbers in. So we have 0.10 molar times 15 milliliters divided by 0.15 molar. Molar cancels. Throw that through. 10 milliliters, good. And I would probably put 10 point, so I had 2 sig figs. So titration is just a dilution, basically, equation. Okay, are we okay with that?
Yeah.
No? We're okay? All right, I'm going to move forward. Explain how to set up a titration. Okay, you tell me what we need to do. I've sort of gone over it. I have a known concentration of a base. I'm using 10 milliliters of unknown acid. How am I going to set it up?
You put the unknown in the beaker at the bottom.
Okay, I put the unknown in the beaker at the bottom. So here is my 10 milliliters of acid. Okay, now what?
You do like that dry thing where you like do the
Okay, I prime it
And then
with what?
the
Indicator.
So the NaOH.
With the NaOH, what I'm going to put in it. Okay, now I'm primed it, and I've got it to 0. I'm going to slip over, and this is NaOH. There's one other thing you forgot.
You have to put it above and then you rip it off.
Right? Okay, what else do I need? There's one other thing that you've forgotten. It's really important. Yes.
A pH scale.
No.
Sort of. Help him.
30 seconds.
Drip it first.
No,
The stirring?
no. He was on the right idea. Indicator. If I don't put an indicator in it, I don't know. It's like running a race and not knowing where the ending is. Okay, so you got to make sure you put an indicator in. Don't put a lot. 1 to 2 drops is good. Okay,
What's the indicator?
like phenolphthalein or the universal indicator, something like that. Okay, I'm going to pop through this really fast. So, learning check. You have a bottle of hydrochloric acid, which is 12.1 molar, which is the strongest we can get. You need 400 milliliters of 0.1 molar hydrochloric acid. How much of the acid do you need? See if you can do it real fast. Learning check. I gave you this, which is basically C1V1 equals C2V2, or CAVA equals CBVB.
What were your idea for syntax?
I got.
That's what I got.
Did you get it?
Yay! I did
It should be very easy, very fast. It shouldn't be very long for you to do this. Okay? It should be very quick.
I don't know what to round to in this equation.
So we have 3 here, we have 4 here, we have 2 here, 2 wins. The smallest amount wins.
Isn't that 3? Because it's 0.
0 doesn't count. That's just a placeholder. If it's before the decimal, before a number, doesn't count. If it's after the decimal, before a number, doesn't count. Okay? So if I went 0.010, okay, it's got to tell me how well I measured. Okay, so we're going to head back to lab. This is what I want you to do before you move. Listen. When you go back to lab, you need to get goggles on, either an apron or a jacket. Please leave any jacket or loose things like your lanyards here, because they'll get in the way. When we get back there, after you got that on, you got glasses on. Okay, important. Listening. Okay, I set it up in groups of 2, but each of you get your own stuff. So I need one of the people to go up in the front, and there are the stirring rods. You'll need to grab that and the pH meter. The other person needs to come back in the back with me and get the stirring plate for the last part of the titration. Okay? They just were so heavy. I need you guys to help me with this. Okay? And then we'll get in our area, and I'll walk you step by step through it. So take your lab back. I am going to check you off as you go back to lab to make sure part C is done.
We need 1 or 2.
One string plate. If you didn't finish it, then when we get down to a point if you got a stamp for all of it, just give me all stamp. Yes, you'll need a calculator. Yes. Need a calculator. Oh, it's for part C. Oh, better, yes. That I can actually see when you put it up, yeah.
Can you restate that for me too?
What?
Part C. Okay, you need help getting part C done, or are you okay?
I'm good.
Okay, I'm gonna stamp it because you're almost there and then come back. Because I am running out of time to get back there.
Are glasses okay or goggles today?
Glasses are fine. We'll be getting new goggles here pretty quick, and then I'll say goggles. But I know how bad they are. So I'm not going to force it. Okay, remember you need a calculator too.
Giovanni. Just kidding.
Okay, one last call. Every group should have one stirring hot plate. And you should have a stir bar, an easy leak, and a pH probe. Stir bar for your stirring plate, an easy leak, and a pH probe. And then undo carefully your urette. This is what you're looking for, your urette. Some of yours will be like this, and they'll come up like this, and you can put it in. Others, like this one, you just going to flick it like this and put it in this one. So depending on what kind you have. Okay? And then, no, shut the box and pour me some in the garbage can. I just didn't want to open all of them. Okay, we're going to get them in just a minute. Go ahead and leave your pH probes in the boxes. Make sure they're standing up. That's really important. Do not lay these pH probes down. They have buffer in them to keep the glass wet. If the glass dries out, then it ruins the pH probe. If you open up your pH probe and it doesn't have any solution and 50 milliliters. So either the medium size one or the small one, whatever you have to mix up, that's going to be your garbage beaker. So make sure you put white on it so you can keep track of it. White paper. Yes. Right. Right. So orange on two. So each group, every person needs one like this. Every person needs one like this. And every person should have a garbage beaker. If you don't have an extra garbage beaker in your area, there should be some more on very back parts or back part back there. Yes. Garbage beakers, if you don't have another garbage beaker or bag for every person, grab a bag. No, you just got white tape. You need to have a small beaker with that. Okay, so. Right, you should have two extra beakers. Okay, you should have, each person should have this plus the garbage. Your garbage might be little or big. Okay, but you don't want to use the biggest ones. Let me just say that. You don't want to use the biggest ones. Each person needs four. If you need more beakers, don't very fast. I tried to get everything out, but I might not have made it. Guys, you gotta move. Okay, if you're done, I want you to go and get some of the red and put it into your orange beaker. Get some of the blue and put it into the beaker you have not put stuff in. So really quickly go to your area and grab some red, which is your unknown acid, and put it in your orange tape beaker. And then take some of the blue, which is your known sodium hydroxide, and put it in the beaker that you have not labeled. Just pour it at 50 milliliters. Might have to come back. Yeah, don't use that big beaker. Do not use it, don't use that. Use your small. So I'm just doing the small beakers now, full of chemical. The orange one should have your unknown acid in it. The unlabeled is your base. Okay, put your garbage one underneath your red. Yes. Two small beakers and one garbage beaker and a glass. No, you should have another one. So we'll grab another small one. Okay, there should be some empty stations around maybe because there wasn't everybody here today, so fill out their station. Right here.
The orange contains the red. The orange one red and the unlabeled is blue.
Unlabeled is blue. Orange is the red. I ran out of tea, sorry. Okay, but you should say tea. You had tons of orange. So we're gonna go orange. Okay, we're gonna have to move a little bit faster, guys. Please put the garbage in the garbage so it's out of the way. Yeah, that's the part. You got two orange there. No, two orange, one more. So, you need one more. Okay, is everybody got their chemicals? So, you open it like this, and then you put it in. you one of the parts that where did it go? There's one right there at the back. So, yeah, you want to rinse it all the way out, but in the process, I want you to practice stopping and starting it. So stopping and starting it until it's all out. This is practice. This is technique. You've got to be able to do this. We're going to be doing 2 lots of titrations. So I want to get to the point where you can stop it, 1 drop, add 1 more drop, stop it, add 1 more drop, stop it, add 1 more drop, stop it. Okay, add 1 more drop, stop it. Because it might just be 1 drop that is the difference between low and upper top. Okay? So practice 1 drop, 1 drop. When it's finally all drained out, go ahead and close it. And then I want you to refill above the 0. Once you refill above the 0. Above the 0 line. And then I want you to bring the bottom of the meniscus down to the 0 line. You can go get more chemical, go get more chemical. Very top. Same chemical, don't use your garbage. Don't use the garbage, it's done garbage, don't use it. Because it's rinsing the chemical inside this, that priming was rinsing it. Getting all of the gross stuff, you don't know what was in it before. Okay, while you're doing that, I'm going to go get these right in the box. Okay, once you got that done and it's down to the 0, come back here and get the pipe out and pump. Yeah, you show us what you have to do. So using the or red pumps, the green pumps have had issues, so if you use the red pumps, you should be okay. Open up your pipette, so go back once you get that zeroed out, give yourself a pipette and a pump. Like that in the pump. Bad corner. Okay, you're going to push it together like this. Yeah. Well, yeah, you can usually both use it if you want. Okay? So you can trade back and forth with this with your partner if you want to. Okay, now, yes. No, that's just your garbage. I'm going to use this garbage all the time. Close it, fill it up above 0, bring it down to 0. Back in the close. Yep, all the way above 0. Okay. This is for your unknown hydrochloric acid. Watch me really quickly. This wheel sucks up. Okay, this wheel sucks up. You can do 1 of 2 ways to get it out. The easiest way is to press the side here. We're releasing it into your teeth. Be careful that while you're pulling this up, I don't like that they have the release right here. A lot of kids bump it. So make sure your thumb does not bump it while you're pulling it up. Okay? Yeah, you can go away with it. You can also just go like this to put it back in. Okay, so you can pump it up and then you can put it down. Now, this is backwards. So you're sucking up to 0 and you're releasing all of it. So you're going to put it into your beaker that has your orange and you're going to put it at an angle. That's important. You put it straight up and down, it'll cause a vacuum and you won't get it sucked up. So you need to go going into your flask by doing the side here or by pushing down. Either way will work. Up to the 0. So it's 10 milliliters, 10.00 milliliters. Out of the orange. Okay, then just sort of set that aside because we're going to be using it again. Again, try and keep your beakers back away from you so that you don't accidentally bump them.
So I am practicing taking out of the.
When you get to that point, I want to hand grade so I know your group's ready. No, you're doing it out of the orange beaker. Orange beaker into the orange flask. Orange beaker into the orange flask. Everybody's doing their own. Orange beaker into the orange flask. Up to 0. Bottom of the disc is up to 0. We're going to be using the same thing over and over again. So you got to get used to doing it. Okay?
Wait, which 0?
Up to the 0. So it's 10, 12 milliliters. So to release it, you either push the button on the side or you got to move it fast. You got to have your beaker real close to it. Your flask. Make your flask. Okay? Into your flask. When you got that part, raise your hand so I know your group is there. Just pushing it in or letting it go inside. Okay, those of you with your hand raised, find phenolphthalein in your chemical.
If it starts going down after you finish doing this, that's all.
You gotta really quickly hold it and move it into the flask. So you're done. You got stuff in your flask.
Oh, you want
Okay, only once again. Okay, 1 to 2 drops of phenolphthalein into your flask. Everybody's doing it. 1 to 2 drops into your flask.
where?
Phenolphthalein. Into your flask.
Hey, is this a good idea?
That is the one we just put orange stuff into. This is a flask. Erlenmeyer flask.
You have to hold it.
Now, I personally like to take a piece of paper that's white and put it underneath where my garbage paper was so that I can see when this changes. Because the black background, I cannot see. Okay? So I'm going to hold this up so you sort of see what I'm doing. You're going to take, you're going to go drip, drip, and you're going to swirl this with one hand while you're dripping with the other hand. Okay? So you're going to swirl it. What did I tell you? Has to turn pink and stay pink for 30 seconds. Okay, now I want you to try it. Okay? You and your partner both try it. I have to swirl with my right hand and I go on my left like this. So I'm holding this like this around and using this to turn. Okay? That way I'm not putting too much pressure on the burette. I won't break the burette. Okay? So you got to be careful. And I like my burette to be real down low. It needs to stay pink for 30 seconds. No, you stop. You need to turn this pink to stay if you stop. Stop. If your stopwatch is really tight, there's a on the other side, undo the screw just a little bit, and then it will be a little bit easier to move. 1 to 2 drops. Okay, so there's the pink you're looking for. Okay? Then you're going to read how much you use and put it into your lab notebook.
How many drops are
Where do you know?
in
Just remember I said drop, 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 drop. Phenolphthalein, yes. And you see mine is just very pale pink. All you're going to get, that's why it's white underneath. Little word C. Okay? Once you've done that, you're going to refill it up and do it again. That's your second trial. And then we're going to set up the next one in just a minute. So, I'll let you do that real quick and then we'll get the next one set up. mean, too much, you know, so if you're getting a very, very bright peak, that means you have too much put in. So practice again right now on your bag, how much you use, you fill it up, dump out your solution, you fill it out. No. 30 seconds. So how much change backwards from the G's? Which solution? I mean, this one or that one? I know, but where did you do it? Here, right there. How many times did they not change? And yours is not changing either? Did anybody in the front do it right here? No, I'm asking the front. Did any of you in the front do it right here? And did yours change? Okay, so those of you in the back, what I'm going to do is dump it, drain all the way out, we'll get some chemicals from the front. We'll turn all the chemicals out, turn all your chemicals out, and clean things out, and we'll get chemicals from the front. Okay, and then what we'll have to do is take you and your partner, and your partner,
My process like so slow.
so this is problem solving. Who has it to bring up? I can repeat it now. Yeah, I can repeat it. Which line is your name? No, the whole thing was repeated. So like, and that's okay. Yeah, it can go down to the salt water.
special.
Okay, I'm gonna put it up on the board for those who are ready for the pH. You can follow through. On the pH, here is your stirring plate. You're gonna set up your beaker. You're going to put in 10 milliliters of the acid plus 2 drops phenolphthalein plus 200 milliliters of distilled water. That's a change. Okay, so the pH, you need to have a little bit more water in there. So that's why everybody has distilled water. You're going to add it to about 200. So put in the 10 milliliters first, put in the 2 drops, and then add it up to about, with distilled water, about the 200 mark. It doesn't have to be exact. What did I just say, guys? Okay, it doesn't have to be exact.
So, was the initial zero?
Zero. Okay, once you get that going, you're going to undo your pH meter. Your pH meter looks sort of like this. I'm not an artist. Okay, you're going to take some distilled water and just sort of rinse it over the end of the pH meter. Then put the pH meter in. So it's just covered. You start to loop it in there. You're also going to add your stirring rod. Remember, be very careful with your stirring rod. You might want to start your stirring rod first before you put your pH meter in. Get it stirring low. You just want it turning slowly. Okay? Oh, you don't need to slow down. Okay, those of you that have a lot of acid, we're just using 10 milliliters, so will you share with somebody that doesn't have any, so they can take 10 out of yours? The titration tube above, guys, is set up the exact same that we've been doing. So your titration tube set it to 0, get it ready, and when you're at that point, let me know. We should be at that point in about 2 to 3 minutes. So you can get this over with that. You need a calculator. You need an easy link. The pH probe to be easily condensed to the calculator. Yeah, you just do it again. Run it again.
Oh, dang it, I overdo it. Oh, that's good. I like my two drops.
Okay, I'm gonna go through.
Now,
Yes.
This is the ones that.
Well, you didn't dry out your cylinder pile, it's probably why it did too. It's reacting with the water.
Okay, we're gonna go through this last one really fast. Those that are with me, great. Those that aren't, I'll try and go through it again for you next time. But here we go. How many are ready with the pH meter? Okay, so you should take your pH meter out. You should hook it up easily. You should hook it up to the calculator. Somebody following with me that in your group. It should come up with a reading. The reading should be about 4 point whatever. It's still in the solution. If not, it might not be there. If it doesn't come up, go out and immediately. If you've already put it in your solution, it should be around 2-ish. Okay, so mine shows 4.7. Okay? Then you're going to take, now watch me, this is important. Leave the lid on the pH meter. Unscrew the bottom part. Unscrew the bottom part and set it aside somewhere you're not going to let it spill. Then you're going to use the distilled water and rinse off this end. Okay, you're going to take this portion of distilled water over it on your sink. Okay? Then you're going to put it into your solution. And you've got it on like these guys over here. Make sure you put some indicator in it. It should be clear to start with. Otherwise, if it's pink, it means it's already taken. Oh my God. Okay? So it should have indicator in it, should be clear. You should have your stirring rod in there going slow. Then you're going to set up the titration tube just like you did. Up to 0, and you're going to start with. You're going to start with setup, events of entry. So you're going to have number 3, events of entry. Okay, events of entry. Setup, events of entry. Then it'll look like it's back to the screen you had originally. You just put start, and it will come up with what is your entry. So, your first one you knew maybe that I stopped at 8. At 8 it changed color. So, until I get to 7, I'm going to have 1 milliliter at a time. I'm going to here. Okay, I have 1 milliliter. And the first one's going to say, okay, P, 1 milliliter, 1.0. And then you're going to have 2 total milliliters. And you're going to go P, 2.00. You want 3, you want 4, all the way to 7. Once you get to 7, you're just going to have a few drops in the P. Because you know it's going to change colors. Okay? You know that curve's coming. So you're going to slow down. Once you get past that curve, you start seeing this appear on your calculator. Okay? And you get to the top. Then you can go back to 1 milliliter, 1 milliliter, until you get the whole curve. Okay? That's the zero. And the blue. So, the one that doesn't have anything.
This does not have a big seal. This is just a drop. Oh, just like you. Let's go.
Now, if you did not get through your tutorial, you need to come in and see me on Monday's tutorial to get it done. Please make sure that your pH strokes are not laid down. They're standing up and you put them into the box correctly. So you need to rinse everything out because it'll go bad. Rinse everything out. Okay, this is really, really important. These are brand new burettes. I do not want them to get messed up. The holes at the bottom of the burettes are so small. Get all the chemical out of it. Run a full burette full of distilled water through it. And then when that's done, put it upside down, open, and so it will run away from that small hole. Okay, so it doesn't clog. Okay? You can leave the pH meters, you can leave the easy links at your station. Make sure you put them somewhere where they're not going to fall over. Okay? Yes. Pour all your chemical out and into waste, rinse everything out. Mix
I love
them
mixing
together
acids.
before you put them down the sink, and that will destroy it. Still waters and jugs.
Where are the washcloths?
Sorry.
What do we do?
Draining everything out, they
Let me
get
put
stuff
my
out of
trolley.
it. You use your pH meter for it, little pieces, whatever.
sets the mood for the rest of the day.
Chevy, you clean up now.
I haven't gotten through that step till half the time.
Probably give you like an actual experience. Yeah, he's not
How do I have two calculators in my hand? I had one when I came in. What? That was freaky. I had one calculator when I came in, and I walked out with two.
Because I gave you one. And I said, will you put this up for me?
Because I put that one away, and then I looked down at my hand, and I still had one. And I'm like, what? It stinks like somebody accidentally drank like all the chemicals because they thought they were water, and they thought that was nutrition, and then they had to like go to the hospital.
Did you write the chemicals?
Wait, are you junior?
Stupid
I'm senior.
Oh, okay, yeah, 2 more months, right?
Yeah.
2 more months. We're almost there.
Yeah.
That would be sad if it actually happened.
But this is a kitchen,
You said it's not
I'll cut hard at the glass though.
and people just put water in because that's smart.
You don't hurry.
See you, Shannon. Wait, Shannon.
Hey, what are you stealing? I'm not stealing anything.
You're doing the opposite of stealing.
What if I be stealing? I'd be stealing someone else's stuff. I know you stole it first.
Wait, if I stole it first,
Let's
isn't
go.
that good?
No, fuck you.
I mean, dude, it's like,
I won't buy back to me.
wait, why did you do that? Now I have to do licky on my dicky. You see, hear that? That's the sound of a man.
Wicked sounds.
Oh, do you guys want me to bring my Aztec death whistle here?
Yes.
It sounds like a woman screaming. It's literally just. I'll bring it. I'll also bring those little like night game.
I can finally drive myself.
Oh, did you get one of these? You'll need one of these for next time. Oh, okay.
What are these for?
I have no idea, but you said that you needed to grab one.
Just not coming back to school or anything. Just like this. I was like, but I paid money for this class. Like, I gotta get my money's worth,
I'm not gonna get my money worth if I'm gonna end up failing it. It's not worth
Well,
it.
but you can still get the high school credit. You know. So you can get the high school
I
credit.
did not.
I've actually, like, I thought about retaking this in college, but it was like, you're gonna kill me more. I just don't want to fail, because it's not gonna look good. And seniors can't fail their last term, so I was like,
Yeah, that would screw you over.
so I was like, so what's going on? I knew that in order for my grade to be somewhat good, I'd have to. Caitlin, do you have your labs done? Like which one? Any of them? Yeah.
I don't have like the last one we did, like in the packets. I don't have those.
I'll take that.
What's the
Now
matter
how
with
we have that group chat thing.
What's the matter with you?
Would you be?
Always blaming
No,
me.
I'm not part of
Well,
You're not.
because
What?
unlike
What do you mean
you,
you're not
I
part of
don't
the
have
apartment group chat?
That was crazy.
The road to group chat? Oh, scared me from that. I was like,
I thought you meant for this class. I was like,
we don't have one of these.
That first titration is always rough.
I think every single lab for me is always You said you're supposed to get a light pink, and I looked at mine and I was like, something's wrong with this shade, and it's not going any lighter.
Well, I didn't make up those solutions. I went with something that I already made up. So I know better than that.
At least I got a pink. That was my biggest worry. I was like, what if I don't ever get a pink? My biggest worry was just getting to a pink.
I put one.
And then I was like, then we'll just lighten it
Right
up
away.
and see light. And I was
You'll be
like,
Right, because you didn't dry out the beaker.
thanks, guys.
Because water. Wait,
welcome.
Does phenolphthalein turn pink in water automatically?
Does what?
Phenolphthalein?
No. If it turns pink, you're in trouble because it's a base.
Oh, quick.
Oh.
Because
So
when I did my
And the
second trial.
NaOH is what made it pink, right?
Did you put OH in your beaker instead of acid? I might have actually. Because I put like one drop of indicator and it turned pink right away.
And you know right away it's wrong.
Yeah. Well, great.
That's what one group did behind you guys, didn't it?
I took a little bit
I put too much.
before it hit.
You
And
said-
mine would turn a little pink. I'd mix it and go back to clear, and I'm like, this isn't working.
That's 9, yeah, I forgot to put back.
I
in
just
the
got-
binder.
I just got it all backwards.
Yes.
I don't know, you get a lot of things
Backwards. What's backwards?
That would be the
You
worst
don't
thing.
know what backwards is if you know what forwards is.
Seriously, it would be the worst thing you could do. You go in this class and you have a chance now to get a grade.
Oh boy, here comes
But
the
if you
challenge.
don't,
So,
and
We have
the
ourselves.
We've got nuclear,
Do you know who
nuclear,
Alex
you
Boat
can add or subtract, you got it. and
something is
Organic has no.
short kid with black hair usually wears beads. He's also really annoying and doesn't know what personal space is. Oh,
Get it done. Don't just give up, get it done. Come in, get help. Come in during lunch, I'll open it up for lunch. Okay, just come in, get help. Okay?
measurement. Your blood glucose is 125 milligrams per deciliter. Meter is searching. Meter is searching. Successful. Successful.
office. Brinley Hatch to the attendance office.
messed it up again, I know. The room. Everybody's freaking out. I'm like, I didn't like that I couldn't get over there without having to go around. So I messed it up. I'm tired. And it's Friday. And it's the last period of the day. This is to remind me to take some distilled water home. Got anything fun planned this weekend?
Anything fun? Sleeping?
Sleeping.